Someone switched it off. Should we start with the... Where are the blue sheets? I left them here.
Yeah,
You already sent them.
yeah, I already sent.
Okay, maybe we can start, huh?
Yeah, it works right. Can I use this to control?
We need to plug it here. Check it.
We can play and let me try.
Right?
Okay. Hello. Okay, guys. I think we can start. So, good afternoon. Welcome to Ccamp session. So, I think, for many of us, it's the second time for us to be in Berlin for IETF meeting. So right now, this time I see a huge number of the participants. That's good, So look at the picture. I think Berlin is really beautiful and it's more safe, compared with other place, because there's low, neither chunk attack nor train attack, right? So, okay, good. So for the lot of wear, I think you are familiar with this kind of rules. So, by participating with IETF, you agree to follow IETF process. Yeah. So as usual, we also have the audio recording. So please speak in front of the mic and state your name before speaking. So for the minutes, we really appreciate if anyone can, take minutes or input something during the meeting on the ESPAD, because it will really make the chair's life more easier, much easier. Thanks. And also the chairs will monitor the chamber and also meeting echo. So if there are some comments raised, and we can discuss. So here is the session, and you can see the agenda and the materials through this link. So for the agenda, so we can see that the agenda is really busy. So we grouped some topics. So for example, for the Flex E topic, there are 5 drafts, and we group into 2 slots. So here we really help the presenters to use the time efficiently and quickly introduce the, some new things or updates, and then leave some time for discussion, And also maybe, for next time, maybe we will ask more time for the slot. Yeah, okay. For IPR process, usually we know that when we move forward to the next step, the chairs will send out the IPR polling, And for example, before an individual draft becomes a working group document, or a working group document goes to last call, and the chairs will send out the IPR polling, and the authors or contributors have to respond this IPR polling, and to make sure that you follow the IPR rules. This is very important for all the participants. Mailing list. So yeah, we usually encourage people to use the mailing list as much as possible. And because we can discuss any open issues, any open technical stuff. And also we can use, for example, use the list to introduce some new ideas, new drafts. And, the working group consensus is determined on the list rather than in the, face-to-face meeting. So even though we got some consensus in the face-to-face meeting, we still need to bring it to the midst for confirmation, for confirm. So this is quite very important. So it's better for us to use the list actively. Okay.
Okay, so let's go briefly through the status of the working group. Since the last meeting, there is actually we have a new RFC 7892. It basically modifies the allocation policies of the OTN signal type subregistry. It was recently approved, and it's I would say a companion document to the ID that we have in the editor queue, the additional signal types for G709 version 3. We also have a draft which is in the ISG processing. I guess it was recently approved. Please, Deborah, correct me if I'm wrong. I guess so. And one draft that recently passed the working group last call. We have two drafts that will be, two working group drafts that will be presented today. The framework, the control framework for IP over WDM interface management, and the young models for WSON. We have 4 more working group drafts that want to be presented today. The flexible grid OSPF extensions, which recently passed the working group last call. So it's now in charge of the authors to update accordingly to the working group last call comments. Then we have the LMP FlexiGrid property draft, which is kind of frozen and waiting for feedbacks from our side on how to progress it. We also have another draft, the RSVPT bandwidth and availability draft, which is, we received some comments on the mailing list from the authors. They believe the draft is stable. There are no open issues, and it will probably be the next draft in our backlog to be progressed. And then we have the WSON IV info draft, which recently expired. I don't know if there is any author here that would like to give us an update on the draft. I don't know, maybe Gabriele? I don't remember if you were involved in the draft. I remember Giovanni is.
Gabriele Galimberti speaking. Yes, actually, we are talking to Giovanni to submit a new version just to keep it alive, and then see if it's worth to proceed with this document. I think.
Any open issue that needs to be discussed?
No, I would say no, at least as far as I remind from the last IETF. No, sure.
Okay.
We can, in some way, what we can do is post a new version and then ask for feedbacks on the mailing list. And in case, if everybody is let's say, willing to continue, we can
Okay.
ask a last call.
Thank you.
you.
Then liaisons and communications. We have an incoming liaison, which is pretty new. It dates back to 14th of July. It's about young modules and its generation using technology, using UML information models. We need to reply by September, so there is time, but given that there is vacation and so on, please have a look at it as soon as possible and send your comments to the mailing list. Last but not least, design team. We recently kicked off a design team for radio links. It was created the 31st of May. The design team, as main deliverables, is in charge of producing a problem statement, which is already available. It was recently published. A gap analysis with respect to what is already there in other standardization bodies and so on, trying to align the models, try to not to generate any overlap, not to boil the ocean, as we usually say, and obviously young models for the control of radio links. Governance: the design team meets weekly, virtually, obviously. The calls are advertised on the mailing list. Everyone willing to participate can do that. And this is the list of guys that are actually participating to this design team and are also the authors of the problem statement draft that we will see later on today. So let's move now to the first presentation, since we have a super packed agenda. Rudiger.
Thanks a lot. So, good afternoon. So this is an update of the framework document for the management and control of optical interface parameters. And yeah, we are now at revision number 2.0. We updated the document twice since last IETF. So immediately after the IETF, we had an update with a completely new structure, a new talk. And now we extended or filled the requirement section that was empty since last presentation and the last update. So let's have a short look on the motivation. So the initial goal is, if you want to integrate your line-side interfaces of the optical network into the router or into your client equipment, then there's first of all a precondition to achieve interoperability that you're using a standardized data plane. So this is the first thing. So additionally to that, you need a common model to manage and provision the network. And that's what we are doing here. That's the main motivation, using a common management interface to operate a network efficiently. So, and going further on that topic, you have to consider your operational modus into your department or into your company, and you have to support in some cases a legacy operational infrastructure that is considered as well in the document in certain use cases and as well in the requirements. If you look to the document scope on this side, first of all, the document covers, as I mentioned, the management and control of optical interface parameters. We have described a lot of use cases in the document. We set up a new requirement section as well, dealing with operational requirements, so getting a more efficient operation and provisioning of the network. Yeah, and this is as well a document providing our other stuff based on Yang, the LMP extensions and the SNMP MIP. So if we have a look on the solution space here, we are focusing on two different approaches, let me say. So first of all, the communication northbound towards the management system. Here we are looking on SNMP and Yang, and as well of an extension of LMP, dealing with the exchange of optical parameters between the optical network and the client side. So I already mentioned what's new in this document. We rephrased some things, we corrected errors, and the biggest change is the new requirements section that we set up. And yeah, and the requirements validating, of course, the use cases that we are described in the document. So what are coming, just giving you a short update on the requirements here. So first of all, what we see in current network architecture, so networks becoming more complex than simple. But what we need is a good abstraction and a good way to manage efficiently and operate efficiently our networks today. So this is one key requirement, what we need. A simple way to manage and operate the network, even if the entire architecture becomes more complex at the end. Yeah, and as I mentioned as well, data plane interop is a precondition for us, as defined, for example, in G698.2. Yeah, okay, and then another point that we are addressing as well in our deployments, in our current deployments, is a more tighter interworking between the transport layer and the IP layer, so that we can achieve a better traffic engineering, that we can achieve a higher link utilization, and of course a better view on all the network characteristics. Okay, so let's move to the next steps. We already submitted the new version, and we want to introduce a discussion on the list as well, so getting some feedback. Next update, I think, will remove text that is not needed and a further clean up. And yes, for the Yang SNMP and for the LMP documents, we started a discussion with the chairs. Chairs was invited and with a lot of experts. So how to proceed with that document. So this discussion is ongoing. And yeah, that's from my side. Any questions? No.
That's great. I have a quick one. So I read the new version. The text is pretty better. It's clear. I just have a comment on one of the requirements when you speak about better integration between IP and WDM. I think that you should be a little bit more clear on what you mean there, and which are the aspects that you want to address. Because here you're saying we want to address management and control. Mm-hmm. So what are the what does it mean better integration from management point of view? What does it mean better integration from the control point of view. This is, in my opinion, something that is still missing in the draft.
Okay. Thanks a lot.
Any more comments? So actually, I have a few comments from a chair point of view. So actually, there's a section 1.1 about requirement language. So it seems that you are going to use RFC 2119 language, but actually you didn't use it. So please check if you are going to use it or not. If you use it, if yes, then use this language very correctly. Otherwise, just remove it, right?
Thanks for that comment.
Yeah, and there's another second comment. So in the requirement section, that's good. You list a lot of type of requirements. And also, you know, there are multiple, many items talking about LMP should be used to do something right. Mm-hmm. But you know, LMP is a kind of optional protocol for GMPS. So from my understanding, I think it's better to say LMP could be supported. You know, actually there are multiple things to exchange something between the endpoints of the, you know, blank link. Mm-hmm. LMP is just one of the, you know, option. Okay, yeah. Thank you.
Jules-Emerick, I'm in line with Patai's comment. Thanks for the work. Supporter of the draft globally. But specifically on the requirement number 9, you say LNP should be used to automate the end-to-end connection setup of the optical connection. That seems RSVPT-based feature in usual architecture. So you still need some respin of the draft and take care of those. But
Right. Yeah.
Thanks anyway.
Thank you.
Thank you. Yang, please.
Hi, my name is Young. We have a bunch of authors. We don't mean to have 4 Huawei authors. It was 3, but we added 1 because of transfer or joining Huawei, Aiwa Guo. And we have Victor Lopez and Dan King and Bin Young from ETRI. Update from the previous version. We didn't add any new content, but we align with all those import other modules and augmenting from more general definitions from T and T topology and so on. Oops, I'm sorry. Yeah, so basically that's what we did, and luckily today I was able to make Pyang validation passed. I don't know how it happened, but it happened. Because previously it failed. I don't know why it failed, but now it passed. So that's the good news. So I don't want to be good news. So I don't want to change it too much at this moment because it may fail again in the future versions. But that's kidding. Sorry. Yeah. So this is basically Yang tree, and we kind of align with augment. You can take a look at what we augment, what we are imported some generic parameters from. Current version is very bare bone. I think next step is we have not defined wavelength definition. Oops. Because the label definition has just evolved to be very generic on the top, and then so WSUN has a little bit different label representation. So we have to augment from the generic label space. So based on oops, what's I should not touch that. Based on 6205, and also port label restriction needs to be added. We have a connectivity matrix, but we don't have label restriction yet because of the label has not been fully defined. We didn't want to start wavelength label first because we are now, augmenting from general label notion from T topology draft. So we're going to augment from T topology for wavelength restriction. And any missing WSUN parameters, I'm sure that there are many that will be added onto this document. And we have a separate flex grid document. I don't know, Oscar going to present later. So I think so far we have a decouple from fixed and flex at the moment. I think that's all I have. Any question?
Dieter Bella, Nokia. I have just a question for clarification. I suppose that the bitmap that you're talking about is the same bitmap that we have defined in the WSUN OSPF extensions, right?
Yes.
Okay.
Yes.
So you will probably use a similar encoding also in
Right.
the YANG module.
Yes. I have a question for you. Bitmap is most compact one, but there are other ways to like range and all those
Yes,
things.
but-
Do you think we have to inherit that or just bitmap? My take is bitmap is good enough.
No, I remember, I don't know in which meeting it was, but we did a poll and then because we had 3 different mechanisms to
Right.
actually
Correct.
advertise available
Right.
We
lambdas.
we used to have 3 different mechanisms for WSUN, but when we did the extensions for FlexiGrid, we came up with a single one.
Exactly.
So
Okay. I'm fine.
please go on with the single one also in the models.
Okay. Very good.
Gabriele Galimberti, Cisco. Just a very technical question. In the draft, you specify the node type as RODM or cross-connect, optical cross-connect, while you didn't mention anything about contentionless, colorless, and so on. Is that something that can be added or is included inside the cross-connect?
I think we can add those parameters, no problem.
Okay.
Yeah.
Okay, thanks.
Okay.
I was wondering whether it was possible to get there using just the connectivity matrix. It's just allowed thinking. Maybe it's not.
Yeah,
but
probably adding something into the connectivity matrix.
Could you
can
provide?
add
Could
a
you provide what
yeah, we can do
list
it.
we can add?
Work
Yeah, no
together
problem.
on that.
Okay.
Thanks.
Right.
Thank you, Yang. Next one. Oscar.
Hi, good afternoon. This is Oscar from Telefonica. So now I'm going to present you the updates on the YANG model for the FlexGrid optical network. So if you go to the next slide, I'm just going to show them. So why do we need one model for FlexGrid? So we know that we have the generic models, and we have also this technology-specific model covering WSUN, but they were not enough to cover a FlexGrid network. So in this model, what do we want to do? Okay, so what we want is to express how it is a FlexGrid network, so we are able to control it. So we need 2 things, and one of them, at least, is to be able to show the topology of the FlexGrid network, considering the particularities of a FlexGrid network, and so that any entity capable of doing path computation is able to do things there. So, and this is the motivation for what are the components that are modeled. Okay, so the main concepts are taken from the framework that was in the RFC 76998. And also the motivation, of course, is here always try to extend from the generic one. So if you go to the next slide, please. So okay. So just to do some wrap up of what does the model include. So it includes the traffic engineering database that, let's say, models mainly 3 types of node. One of them will be the FlexGrid node, which is pure spectrum switching, which is flexible and is not tied to the 50 GHz grid. So this is the first one thing that is modeled. The second thing that is modeled is the transponder. So we model it as a separate element from which the media channel starts. And also we model another element that is called here sliceable transponder, which is basically don't worry about the nomenclature, we can change it. Is that an element that is able to generate several signals, so it will use several media channels. So these are the 3 kind of nodes that are modeled here. And what we have done now is to extend from the, at least one of the elements extended from the T model. And the other element that is modeled here in this traffic engineering database for FlexGrid is the links. Okay, so the links that, as the same case in WSON, consider, let's say, just model the availability of the spectrum, following also the same approach as in the OSPF one. And then this is regarding the traffic engineering database. So here you see that that we have in the transponders, we have modeled also which are the let's say modulation formats that are capable of providing, etc. So there is still one open question here: if all of this is enough to make computations in a flexi-grid networks. So we know that if you really want to make the computations complete, you might need some information that is not here. For example, you might need also the distance of the links. You might need some information that is not something that it's going to change in time, or might not change in time, but you're going to take it from another place. But if you want to model it, and let's say you want to pass this model to some entity capable of doing the computation, you might need that information. Okay, and then the other element that is modeled is the media channel. This is just this bunch of spectrum between 2 points with a certain width, which is defined also in the framework. And what we have done here is also align with the traffic, with the T topology generic model, and augment it from there. So apart from receiving feedback, which is the obvious thing, we wanted to improve this model, there are some things that we think do not need to be in this draft, or might be better in another draft. So one of the things is the media channel. The media channel is something that is really the tunnel. So we think it would fit better if we had a separate document where this media channel, or the network media channel, is treated as a tunnel, so it extends from the T tunnel model. We think this is something that could be done. Also, we need to decide where, let's say, all these optical signal parameters fit in this model. Here, take into account that here we are in the elements, we are modeling like 2 layers of the modeling. We are modeling the layer of the spectrum, and we are modeling the transponders also, which are, let's say, part of the signal layer. So somehow this has to be related to the different drafts that have been presented talking about the interfaces. It is true that this model does not aim at being device modeling draft, but as it aims at being helpful for that computation, maybe some of the things also need to be referenced here in this draft. So, okay.
Hey, can I ask a question?
No,
Not yet? Okay.
Yes, and just that we think it's good that as the Flex Grid, we have a lot of documents. We think it should be better that the working group takes this document and improves it within the working group. So, yes.
Right. Igor Burskin, Huawei. In the base topology model, we have a concept of tunnel termination point. Okay, and we assume that in OCH layer, the transponders are modeled as augmentation to the tunnel termination point. Okay, is it consistent with your view?
I think not yet. We might align it in that way. Now, our transponder is a separate node with a termination point, but it's treated as a separate node. And would that be also consistent with the T?
No.
So
basically, what we are saying is that node hosts like multiple potential tunnel termination points, and there is a lot of stuff which is common to a tunnel termination point in different layers. For example, this is something that can start and stop a tunnel, right? And it also have topological consequences, because this tunnel termination point could be accessible from certain links, but not from all links. Okay, so this is already modeled. Okay, and it also provides basically
adaptation capabilities, so that whoever uses this tunnel can know how much bandwidth you have for adaptation purposes, and importantly, how you actually can adopt. Okay, so for example, we have two mechanisms: transitional links and interlayer locks. How to actually use it in the interlayer computation. So what I encourage you to actually to model the transponder as augmentation to the tunnel termination point.
Just one clarification question here. So I see that the tunnel termination point you mentioned being the point where the media channel starts. Would that be correct to assume that?
Yes.
Okay. Then, do you think that this augmentation you propose can hold all the attributes of a transponder and all the adaptation capabilities, so that, let's say, in a transponder, we are going to transform from some electrical layer, let's say it would be some ODU4 or even some Ethernet, and let's say in that very same point, depending on how we configure the tunnel to be, it will change. That would be okay to do it with this.
Absolutely.
Kind of
this is exactly how it is meant to use. So, for example, we have this like a lot of things which are common to multiple layers. For example, the tunnel termination points also can say, can I do 1+1 protection, or I cannot do 1+1 protection. Okay. So, but I could also say that I have this much adaptation bandwidth to adopt clients from ODU4 or maybe from other layers. Okay, and which may be in the same or in a different topology described by different augmentation. Okay, so all you have to do is actually to provide the augmentation to add parameters that are FlexiGrid specific. Okay, and that's it.
Okay, and there are some parameters that, let's say, I would like to differentiate which are, let's say, FlexiGrid specific and which are, let's say, optical in general specific. Because I mean, FlexiGrid just means that the output of the signal does not fit in the standard grid. So and it fits in the ITU grid, the new ITU grid. So this do we need to describe it here, or do you think we need to describe it?
That's why you would probably better to augment not directly, say, base topology, but OCH augmentation. Okay, so for example, we have a general optical transponder. Okay, and then you have yet another augmentation which provides FlexiGrid transponder. Okay,
then we would need to do this augmentation here also in Ccamp in a separate in this. I don't know.
The same place where we're doing OCH augmentations, right? So we have to do it. If we do, say, OCH augmentation here, right? So we're doing basically FlexiGrid augmentation here because it's a further augmentation. Okay.
Okay.
All right.
Please. Dieter, try.
Yeah,
I would like to let all of you speak, but we are already out of time. So please try to be quick.
Yeah, I will make it very short. I support what Igor has just said. I think it would be good to describe in this document how it relates to the TE topology work that we're doing in TEs.
Okay. Okay. 2 points. One, I agree with Igor as well. And second one, I would suggest to extend some parameters that are missing. In this case, maybe I can be volunteered to help you. By the way, Gabriele was speaking.
Come to the group.
Okay. Thanks.
So I wanted two comments. One is that the interface we're talking about is essentially an interface parameter. So I think we should look into what is generic to map on the tunnel and what is specific for the interface, because in the end we also need to come up with a MIP. So it's very difficult to define an interface with 5 tunnels where even the tunnel is not yet there when you instantiate it. So I suggest to have a look into how to model it wisely, rather than just say, okay, use the model we use for TS, which is for traffic engineering. Thanks.
Okay.
Can I move this?
hopefully on your slides.
Okay. I'm Jonas Ahlberg, and I'm here with the design team and Luis Contreras, who will help me with the presentation, perhaps only questions. But we're going to present the problem statement for microwave radio link interfaces for management of those interfaces. And Daniele, you made the introduction earlier on. Thank you for that. So I can move directly to the second slide here about the scope. Daniele, you mentioned this as well, that the problem statement is the first step only. It's going to be followed by gap analysis and later on also the definition of the actual Yang data model for radio link interfaces. But the problem statement should be seen as a framework for management and control of radio link interfaces, including their relationship to other types of interfaces that exist within a microwave node, and that would typically be an Ethernet interface. Other interfaces, other types of interfaces, other functionality in a microwave node is outside the scope of this problem statement. It's expected to be covered by other existing or emerging data models. The title is talking about microwave, but the scope covers also what's labeled as millimeter wave. So we're talking about radio frequencies from 6 gigahertz up to 100 gigahertz and above. It does not cover radio link functionality that resides within 3G, 4G, 5G, and Wi-Fi type of base stations. So it's sort of within what typically is referred to as the microwave domain. The resulting data model is supposed to be applicable for both traditional network management systems and unified management in the context of SDN, software-defined networking. So the problem statement defines the need for a Yang data model for radio link interfaces that, firstly, is aligned with how other interfaces are modeled within a microwave node. And here I'm talking about augmenting or leveraging this interface management model in RFC 72223. But it could also be that we align with top models or schemas being discussed and defined within the NetMod working group. It should also support feature and product-specific extensions in order to allow for introduction of new features, innovation, and cater for differences that might occur between implementations or products in this domain. The model should also consider the two ongoing activities in this area as starting points. There is one activity going on within ONF, modeling a microwave model, starting with UML. And there's also the IETF activity, the draft that was presented at the last IETF 95 meeting. And of course, this model should also support the use cases described in the problem statement, covering areas such as configuration management, fault management, and performance management. At this point in time, we have, one open topic. The second one has been discussed, and we believe that we have a resolution on that. The first one is related to the need we see for allowing feature and product-specific extensions to the standardized model. And we would like to understand if there's a generic approach or a generic guideline that we can rely on, and not sort of invent this specifically for this particular model. The other open topic is related to if there's a need to describe use cases for that provides an abstracted view of a microwave node, in addition to the possibility of operating on each individual parameter in a microwave node. And there we have had discussions, and the plan is that yes, those use cases will be included in the problem statement. And the last slide here, we published a 0.0 version at the cutoff date, July 8th. We are here to collect feedback from you guys, the working group. We will resolve the open topics and as soon as possible submit a 0.1 version, and hopefully after that reach working group adoption status. We also plan, and we would like to know if that's okay, to in parallel start up work on the gap analysis and possibly also of the definition of the actual Young data model in parallel to sort of closing the first step.
Okay.
And I'm looking at the team here if I've forgotten something. No. Questions? Comments?
Anyone? Okay. I have two questions. Well, first of all, the document is very well written. It was easy to understand also for someone like me that knows nothing about microwave. And this leads to my first question, which you partially replied to, which is you said you are covering microwave and the millimeter wave use cases.
Yes.
My question was it possible to make it more generic to cover all radio links? You already replied it's out of scope. So my question now is why? Is there something totally different that is not possible to have a common model? Because, you know, we would like to avoid next year to redo everything from scratch for Wi-Fi or 3G, 4G.
I can start to reply, and the other guys on the team can help me. But my view is that there are some similarities, but if we should have the ambition to create a union that is suitable for all types of radios, then that would be such a small union that it would be questionable if it really adds any value to standardize it. Because there are differences, and just talking about frequencies that is not so good enough. And then when we're talking about microwave, then there are particular things that need to be catered for, such as protection, 1+1 protections. We are not, at least not initially, dealing with the point-to-multipoint type of solutions, which is the case in most other technologies.
Okay. I understand. Please, I mean, it seems you already have good thoughts about that, but if you see room for making it generic, please go ahead.
Yes.
Otherwise, if it doesn't make sense, no worries. The second is more an editorial comment. You define the radio link termination and the carrier termination.
Yes.
You introduced them at the beginning, but then you explained them after some pages.
Okay.
So if you could start with, it would help the reading. If you could start defining, because everything seems to be focused on those two concepts. If you could move them at the beginning, it would be easier to understand. Other questions?
So one quick comment. So could you move to page 2?
Page 2.
Yeah, actually, you just mentioned that this draft is a problem statement, right? But actually, I think it is a framework, because you describe application and the use case and a couple of requirements. So from my understanding, it's more like a kind of framework. So I think it's better for us to make the consistent understanding on that.
Okay, I'm open. I'm new to this. You see my badge here, so.
But in the team, you have all the experienced guys that can help you.
Yeah,
like the one at the mic.
Just to answer your first question, so besides the fact that both technologies are wireless, there's nothing in common. Microwave is clearly transport, while radio is an access technology, so it just doesn't make sense.
As I said before, I'm totally dumb about it.
Jean-Emerick, Daniele, how can you survive 1 week or every second week in Sweden without knowing anything about microwave? Okay, just maybe a piece of answer to your very first question at the end, to know about integrating gender-specific information into young models. I would go and talk to Benoit Clacy, who's probably the first one to ask. He's probably best guy here to point you to the information other people to talk to.
Okay, thanks.
Hi, it's Manuel Paul from Deutsche Telekom. Just one question on this like second question you had on the like way forward or open topics. So when you say you will think about like whether or not to present or to include, better say, an option to present such an abstracted view to SDN, my feeling would be that would probably then be more like in the turf of ONF, or where it would make sense to align with the ONF work in progress. Would you agree, or is it would it be a different kind of focus here?
No, I fully agree, and that's why we pointed out the two ongoing activities as starting points. That yes, we believe that it's essential to try to harmonize or at least end up on common ground when it comes to how to model an interface towards microwave nodes. Yes.
Thanks.
Amy, Huawei. I want to add something to the previous discussion about the ONF and the IETF work. So actually the ONF work is more focused on the information model, which is a UML model. So what we plan to do here in IETF is working on the data model. So for each individual attributes, they may have a same or similar definitions, but the way of defining, for example, from the top architecture, that might be different. Okay, thank you.
Yeah.
Thank you. Next, please. We are running a little bit late.
So good afternoon, I'm Anurag Sharma, and I'm presenting this on behalf of multiple co-authors and also a lot of people who were involved in doing this analysis, and from multiple SDOs, IETF, ONF, and recently MEF as well. There is a lot of material outside of the slides. We just had 10 minutes, so we have kind of shortened the material. Next slide, please.
You can use.
There was a draft last time that was presented by Jian from Huawei, and there was a comment on that draft to move some of the material out into transport service Yang, which she did, and then we are using this the same draft, I think, to capture the gap analysis for the transport. So with that, let's get into the objectives and the scope of this exercise. So the goal is, what we have seen is that there are lots and lots of Yang models. Everyone is kind of working on Yang models. And when we met at the last IETF, which was in Argentina, we wanted to evaluate how practical are these or usable are these Yang models. Can we actually come up with a couple of important use cases and use these Yang models to represent those use cases and identify what the gaps are. So what we did was we picked a couple of use cases like the single domain network, multiple domain networks, multi-layer, and multi-model, which we'll cover on the next slide. And then identify what was missing in these models, what were the constructs missing, attributes missing, and what the models itself, which models were not there. So, and the non-goal of this objective is, or this exercise is not to look at the southbound of the domain controller, but essentially looking at, this is based on the ACTN architecture or the framework. So there is a network at the bottom, and the network is exposing multiple southbound interfaces. So we are not focusing on those. We are focusing on the domain controllers or the PNCs and going up to the orchestrator. So what you can see is these PNCs, each one, it's a more of a heterogeneous network. Like in the slides, we can come up with a homogeneous network where all the models are from IETF, but that might not be the case in the real world. So what we think is there's a lot of nice work which is going on in the IETF, ONF, and MEF. So all those models probably would end up getting used in the real network. So this is a heterogeneous network where your PNC A is using IETF models, B is using ONF models, and C is using the Presto interface, which is from MEF. And all those are being consumed at the top by the service orchestrator. So our focus point is area is in that red box, which is the mediation function. So if the orchestrator could be based on IETF models or ONF or MEF, whatever. So when the information comes from the domain controller, they should be the orchestrator should be able to map all that information into its own internal models. So we wanted to identify the gaps between these models as well. So not just within IETF, but eventually a use case which is represented using ONF, can it be completely mapped into using the IETF models and vice versa? So that's what we kind of explain at the bottom over there. Model translation mediation. In multi-model environment, deployment use cases must be fully supported by all the models. So model translation and mediation between the systems using different models should be seamless. There's a group which meets every week or every 2 weeks, and lots of people in that group now, and a lot of work has been done there. And we captured some of that over here in this draft. What you will see in this draft is there are a lot of TBDs. Hopefully in the next version, we'll be able to fill in that information. But this is how it's been organized. The top part is essentially the requirements, the transport requirements. And what we are saying is that these requirements are not just for transport. These can apply to non-transport use cases as well. But these are for transport as well. So, and then we have picked a couple of use cases and the scenarios that we discussed earlier, and then we summarize the gap analysis. So next, we'll just go through one of the examples, one very basic example that we picked. This is for a single provider, single network topology. And this picture, some of you might be aware of this picture. This is actually coming from MEF. And they were trying to map a MEF service, EVC service, onto using ONF model, which was the code information model. So we took that use case and we said, can we do this using IETF models? And we came up with a scenario over there with access links and so on. And that's the reason you can see a forwarding domain in the middle. So some of you who have been involved in ONF would realize that that's coming from like the SIM model. So here, this is the instance diagram that we are creating. So we are saying, okay, this is for the topology, this is for the I2RS. So this is how it's going to represent within a system. So you would have a top level node, and it kind of has different children and so on. So this is how it's going to be in your database. And everything in the yellow bubbles, those are the gaps which we identified. Okay, these are the things which would be required for transport and is not being covered by the model right now. So this is the I2RS topology, and then we get into the TEAS tunnel model. Okay, now we have this topology. How do we represent or create a service on this? So again, everything that you see in the bubbles, yellow bubbles, those are the gaps. So some of this feedback has been kind of given back to the authors of the tunnel model. And then how do you represent an access link, or some of the people call it the ENNI link and so on. So we found there was some gap. We had some discussion with the T topology model, and they were really nice and helpful to kind of provide a solution for this, so which is being kind of represented over here in this slide. So this is this was just one example of a use case, but there are more use cases out there, like the multi-layer and multi-domain and so on, multi-segment and so on. So we are working on those. So the work is not still complete. A lot of it is in progress. So the next step is request for comments on the document and overall exercise itself. Something that we already decided that we'll be doing, committed to it. So that's next. We'll be filling in the empty sections and add more ongoing analysis into the document, and provide a continuous feedback to existing models, like where is the gap whenever we identify that there is something missing in the model, kind of provide a feedback to them, and propose new models if something is missing. So that's another objective. And then the potential next step is address multi-model environment use case. So maybe a joint work with other SDOs like ONF and MEF to provide the mapping guidelines between Yang models from various SDOs for various use cases. So essentially forwarding domain, what do you map into for the IETF and so on. And finally, we'll try to shorten the name of this document. It's too long, I think.
Hey. Igor Huawei. Okay, nice to see you face to face. Okay, sorry. Okay, so at the beginning I said that the orchestrator must be able to consume basically models, the information coming from different domain controllers, right? And I totally agree with that. So and it should be totally agree with that. Okay.
We are not used to that. Sorry.
Yeah. No. You have to expect but, right? Right. There's but coming, right? And the orchestrator, by consuming, it means that it just takes the information and integrates it into its internal local in local model. In internal database. Okay. So what I disagree is that there is a need for model translation. Okay. Say for example from IETF to ONF and back. And the reason why I'm saying that we do not model neither say TDB of orchestrator nor of the PNC. What we model is how the basically data store, the TDB, okay, how it's seen from remote. Okay, so that's basically we can accept criticism and basically saying that we do not, we are missing these parameters, okay? We are missing these basically mechanisms, okay? But we do not, for example, care of the, say, format, how the things are coming. So, for example, if link from one PNC coming as 111 and from another comes as a string, okay, in any ways you have to merge these topologies together, and in any way you have to provide like a homogeneous way how to name them. Okay, so basically it doesn't matter how ONF basically model things as long as all attributes are also exist in the IETF model and vice versa.
So I just wanted to understand what you're saying is orchestrator is not going to be following any of these models?
No, what I'm saying is orchestrator will get the models.
And you said it will persist it into its database.
And it will take whatever.
What's the model of the database?
And the model of the database of the orchestrator we don't care about.
No. So that
I'm sorry, guys. We are really running late. Please continue this discussion on the mailing list. I just wanted to add a very quick thing on top of this. You spoke about a group that is working. I see this work as super useful. Putting together what is being done in different standardization bodies, try to leverage on the work that is being done elsewhere. So we already had the chat with Deborah about this issue. We are considering creating a design team for this activity, whose deliverables would be a gap analysis, guidelines on how to put everything together to be able to run a transport network. So if you're interested in this work, we will send out a call for participation in the next days or weeks. So
yeah. The problem is that we disagree what exactly we model. Okay, we do not model internal database.
if we all agreed that there was no need for a design team.
So just a very quick response to Igor's question. So
in the meantime, the next presenter,
there
please.
are operators who are actually looking at these models to kind of model in their orchestrators. So if you see, ONF is already working with some of those operators.
Yeah.
Okay. Good afternoon. I'm Sergio Belotti from Nokia. I'm representing a bunch of co-authors for path computation API. Why we want to present this draft? So it is not known in IETF that controllers and orchestrator are working on a traffic engineering database that is created by the network topology on which controller orchestrator is working. There is in IETF work and already drafts to have a young model to describe traffic engineering network from which you can build up the traffic engineering database. And this young model permit to use RESTConf or NetConf protocol based on this data model description. This procedure, so NetConf, RESTConf plus young model is complement what are already present traffic engineering database distribution protocols mechanism. So at the same time, there is also the tunnel model already in IETF for Yang. So based on the traffic engineering that you can expose by Yang on the TIS topo model, you can provide tunnel and set up the late tunnel on that topology. So what it might be needed for some scenarios that you can have also the need for a path computation API based on NetConf, RESTConf with data model Yang based that can complements what is already there, for example, with other mechanisms for PSEP. This use case, these drafts present in this version some scenarios, use cases to show when this path computation API can be useful and can be needed. But okay, our intention is then to extend the draft, obviously, to provide a young model. So we talk about the need for path computation API, but why for Yang in Yang? So the path computation functionality, it is just one functionality, important functionality that between controller and orchestrator, because controller and orchestrator have a lot of important functionality, and this functionality like service setup, modification, and deletion are already described in Yang. Notification and telemetry information is already provided in IETF in Yang. And so Yang it can be seen as a standard data model for not-bound interfaces. There are some advantage to use that. The advantage that Yang model can reduce complexity because it can be used by NetConf and RESTConf. So reducing the complexity to manage, for example, for authentication, the multitude of protocol. And also in case of external system used for load balancer, it is surely simplify the deal about us using a single protocol rather than have multiple protocols. Above all, there is also that Young model can exploit on the ecosystem. So there is a rapidly growing tool for Young-based API, also for based in open source, already ready in open source. And in case of cloud orchestrator, practically only RESTful API Young-based are used. Okay, the draft.
Yep. Sergio, you have 1 minute and 7 slides to go.
Oh, good. Not a problem. So
decide which ones you want to spend time on.
This is just to remind the list of use cases that you have found in the drafts. All the draft is provided the fact that the role of the optical domain that is providing connectivity. So this is the IP optical integration in which by traffic engineering a database description for TIA topology, you can get the topology abstract node, and then based on the fact that is abstract, you can request the path to the controller, the request for optical path to have an optical path for end-to-end. Okay, multi-domain optical networks is this one, and this is data center interconnection. The conclusion that we had in the draft is that we are facing on trade-off between what could be the accuracy of the information that you would need to make a path computation and the scalability to have multiple information providing at the northbound interface, and also the accuracy versus the updated information, because there is the dynamicity of information that surely needs to have a fast update. So the path computation API can allow the orchestrator to request, if needed, the path that is needed, and maybe in case there are multiple domain, you can match also the abstract topology model to select which domain to use and ask for the path computation request. So at the end, what the path computation API is in traffic engineering topology model is something complementary tool to manage the network. So what we expect in the next step? So first, we are seeking guidance from the attendees, because even if now the use case is completely based on optical scenarios, on the other side, we think that the conclusion and feedback in the draft can be also applied to packet network. And in the parallel, okay, there is a start analyzing of a possible Young model to address these use cases. One could be based on RPC, and the other is a model based on TIA tunnel model extension with pre-computed path. So okay. Then we are.
Let's leave room for one comment.
Adrian Farrell. When I got up here, as I walked up, somebody asked me to be gentle.
Please.
So firstly, yeah, it definitely belongs in T's. You definitely need to talk to the PCE working group, because The consumer of this is path computation, and that is where path computation work is done. I don't believe we need a tutorial on why path computation is useful or how it would be used, which is most of what these slides are. What we do need to understand is why you need another way of communicating with a path computation element when we already have one. Because you can do anything with any protocol. You can do anything with netconf yang. Netconf yang is designed to move information around. And the logical conclusion of this is, well, it'd be really nice to have an API in a router that could be used to exchange information with another router. And then we could put LSAs in Yang models and move them around using netconf instead of using OSPF. And I don't see the motivation for this work. I don't see why we need something else.
Okay, please try to be quick.
My name is Michael Scharf for Nokia, and I'm one of the implementers here. I think Sergio had a nice slide exactly on this, and there's great value in having a single protocol for various reasons, which were on the slide. So I suggest to review that slide because it actually answers a lot of the questions. Why separate protocols for related things is actually a bad idea. So there's, from an implementer's perspective, there's a strong need for that. And the reasons were on the slide deck.
Hi, Oscar González, Telefónica. I think one of the main motivation, at least for me, to come to the to come to the and to, let's say, to support this kind of draft is that there is already an existing T-tunnel draft, the T-tunnel model, which allows you to set up a tunnel. So it is the complement of that one. So if that one already exists on Yang and there is an API to do that, it should be the same also to be able to request information there.
I see different comments. Lou had the similar comments. He couldn't join us. He was in favor of this work, but again agreed with Adrian on the fact that this is something that is probably not Ccamp work. This is another thing we will discuss. Thank you, Sergio. Anurag. We are running late. At this time, I would like not to cut too much. We will still some minutes from the break, if it's okay for you. It's not the biscuit break, it's just beverages. So, please.
So I'm going to be really quick. This is a very simple Yang model for OTN services. The motivation behind this model, the T-tunnel model, is an abstract model to create the T-tunnels. And what we have over here is the OTN service Yang model that augments the T-tunnel model to create the OTN service. This OTN service is created in the OTN topology that's based on the I2RS network topology and the T topology model. I'll skip this slide because I think Gian is going to present this slide in the next presentation. This is the quick overview of the Yang tree. You see the augmentations from for the T-tunnel model for the config and the state. And what we have here is the source and the destination couple of OTN attributes over there required. Right now, the T-tunnel model is point-to-point, but as soon as it becomes point-to-multipoint, this structure is going to change as well. And so we'll update that model. Supported use cases, there are quite a few use cases, OTN use cases, which are supported by this. OTN mux service, book-ended and non-book-ended OTN service, OTN service between the client ports, and OTN service and the tunnel between the network ports. So I just given one example over here for the mux service. It says assume domain 1 and domain 3, they are metro networks, metro domains, and the domain 2 is a long haul. And you need to kind of pass a mux service through domain 2. So essentially you need to kind of provide, okay, what's your TPN number, slot numbers, and TSGs and the client signal, which need to be the same between any 2 and 3, and then 4 and 5. So that's what this slide is trying to show. Next steps, the transport related comments have been given to the T-tunnel model. So we had some inputs for them. And we'll incorporate our model once the T-tunnel model is updated. And we have received some comments on this draft, so we'll incorporate those comments. And we still need to evaluate if this current model is suitable to support the protected OTN services. I think that's it. Thanks.
Thank you very much for being quick. I guess this is is a companion document of the gap analysis that you presented before.
That's
so
right.
basically, this is
Exactly.
already part of the gap that you identified.
That's right. Yes.
Okay.
Thanks.
Thanks. Xian, please.
Hi everyone, my name is Shen from Huawei. I'm presenting the draft for the young data model for the OTN topology. So on behalf of our associate contributors, and here shows you a diagram which the OTN topology sits. Basically, it's actually augmenting from the T topology proposed in T's working group. But actually, I captured all the related topology models, so you see a nice view of how the models relate to each other. And this is actually one of the efforts we presented previously about the gap analysis. So this is about OTN topology. And these two slides, this one, next one, showing you we put the ODU specific attributes in terms of in various of the places like the termination point, the link, and also the schedule part. Because for schedule, you need to show that what type of ODU you actually reserved, scheduled, and which will not be usable by other services or tunnels. The difference, major differences with previous versions that we, instead of augmenting from the generic topology, now we're augmenting from the T topology. So we get rid of the redundant attributes, and we add on the specific ones as I mentioned before. In principle, the topology can be used as a way you initiate the command to create a topology. But the use case, the major use of this model in our case is really giving the topology what's in the network to giving to the clients, so they can manipulate to create tunnels or services. We've already received comments from Hoop and Eagle. They provided very constructive comments. We are working on an update. We may also need some joint work because there may be some parameters that are common, it's not audio specific. In that case, we'll need to consider moving them to a better place. And as clearly we have a multi-party interest in this work, and also I'm aware that a couple of implementations which actually taken this as input. So we would like to ask the W2 to consider to adopt this work. That's it. Any comments?
Okay, now we have two drafts on Flex Ethernet. Actually, we are going to swap the two slots. We are going to see the use cases presentation before and then the framework. So, Iftikhar, please.
So, my name is Iftikhar Hussain. I'm talking on behalf of my colleagues. So I'll be keeping it short and go over the Flexi use cases. Okay, so brief summary. So this draft actually tried to describe a number of use cases which you would need to support if you're carrying Flexi clients or packet network. And so OTN or directly over DWDM. And then also we talk about some requirements which could be identified requirements which actually might indicate a need for routing and signaling extensions. So today we will not be talking about the solutions as just by the chairs. We'll just focusing on the use cases here. Okay, next one. So the first use case we talk here is what's called Flexi unaware transport. So basically you can imagine there are two routers. They are connected through the Flexi group. So people who are not familiar with the Flexi group, as defined by the OIF, Flexi group is referred to a group of 1 to n bonded 100 gig PHYs. So for example, in this case, we are showing two 100 gig PHYs. So this create a group of 200 gig. So the routers are getting a 200 gig bandwidth, and they are connected over a transport network. So in this case, the bottom picture shows, for example, how this will be carried over the transport. So on the left-hand side, they show the stack of the Flexi group. So Flexi clients, Flexi shim layer, and the 2 PHYs in this case. Each PHY, if for example, if it's an OTN network, will be transported independently. So if we have N PHYs, so you will just need separate connection for each PHY. Okay, so the benefit of this use case is that it just keeps a legacy transport. You can use the existing transport because the transport is unaware about the Flexi group. I guess the downside could be that as you can see, the skew, I mean, based on distance, it could be a large amount of skew, which actually the router or the Flexi group termination point will have to compensate for this one. Okay, next one is a partially aware use case. This is the optimization of the previous use case. So in this case, the network, the nodes at the transport edge, for example, A and B, so they're not terminating the Flexi group, but they kind of are snooping, and then they know, for example, how many. Okay, there's a concept of actually slots in the Flexi group, so it knows which among all the slots which are not being used, so they can actually remove those slots and the ingress to the network and the egress they actually insert it back. So this allows actually to match the PHY rate to the optical network bandwidth. So for example, there could be a scenario like subsea or maybe other cases where the bandwidth in the transport network is smaller than the PHY rate. So this will allow you to actually match and make efficient use of the optical bandwidth. But it comes at the cost of that you add a little bit more complexity now at the network edge, because they need to be aware, partially aware about the Flexi group. And from the skew point of view, it's identical to the previous case. The skew still needs to be compensated by the edge point, the router in this case. Okay. Next, step by step.
Try again.
Okay. So the next talks about what's called Flexi termination. So in this case, basically your next hop, so the router and the next edge node, the transport network. So they are the one who actually are terminating. They are fully aware. They completely terminate the Flexi group. And in that case, if you have, for example, multiple clients which are mapped onto the Flexi group, in the transport network, not shown over here, each client is extracted out, and then you can actually route it just like OTN network, any way you want. And then you can aggregate that on the egress point from multiple points. Okay, so the benefit of this use case as compared to the other one is obviously the distance is, you can actually, the skew is limited to shorter distance, and then you can actually make better use of the, you can mux it, much more flexible. But now the edge node has to be fully aware about the Flexi group. Okay. So this talks about another use case where actually, so you can have on one side you have the Flexi group, another side you have a standard existing client. So in this case, what you need to do is actually you need to basically at the data plane need to map some of the coding. There's apparently difference between how the OIF, the encoding of the data in the Flexi versus the standard one. So this will require some encoding. So I'm going to speed up a little bit further. This is another one actually similar to the previous one. This is actually talks about the interworking with the existing OIF standard called MLG. Okay. Then there's another use case. Once I have my Flexi group is configured, set up, this applies to both unaware, all the cases. Once the group is set up, I can actually, there are some in-band or overhead mechanism which allows you to resize. You can add clients, you remove clients, and resize the Flexi clients. So this use case, also can support. This is another use case showing back-to-back links without any transport network in the network. Okay, so this is another use case. So previous use cases, there was an OTN layer in the middle. So this showing another, basically all the use cases I talked about earlier on, one could also support by directly mapping over wavelength. And I think I got a comment from Dieter that this may not be standard mapping. So I guess our intention is not to do any proprietary mapping, but whatever is standard supports it, we will do that. So we'll need to maybe get your feedback, refer to what the standard is, right, in this case. Okay, so the next one is actually the more requirements specified in the draft, but here summarize some of the key requirements. So the solution which will come, they need to address some of these requirements. So number one, we need actually a flexible way to set up the flexi group. And then I need to actually have the ability to actually add or remove the files. So once a group is formed, actually I can actually make the group size by adding and moving files. Then also, once the group is formed, I need to be able to actually add or remove clients without.
So Yiftech, I think maybe we are running out of time, so maybe we can leave 2 minutes for discussion, right?
Yes. I think this is the last slide. So we'll leave for discussion and any questions you may have. Yeah.
So yeah, to save time, I have a few quick comments.
Yeah.
So actually, for the use case, for the current OFIA document, there are only 3 typical use case defined.
Yes.
So, but you describe more than that. Right. Maybe I think you have some, your company specific use case. We have to stick to the, data plan document.
Yeah, so I think so.
Because for example, for the residing, actually Flexi cannot support residing at this moment. So forget about that.
Flexi, adding a files?
Residing, Flexi.
Resizing,
yeah,
actually, resizing, actually, I think we maybe can talk offline. I think that they actually talk about it. Actually, specifically the standard is talking about it. Oh, yeah.
Yeah.
Okay.
But actually, they will be discussed maybe, but at this moment for the current IA document, they don't define the residing for Flexi.
They actually have verbiage. Maybe you can actually refer to the document.
Yeah.
It talks about it. All the use cases except the optical one, I believe that they are based on the OIF. If there's something not there, we can take a look.
Okay. Yeah. Great.
Can I quickly add a remark in that?
Yeah, please.
The OIF is an implementation agreement. The OIF is not a standard body, but ITUT Study Group 15 has recently published or pre-published a new edition of G709, and I think G709 now includes in section 17.11 the definition of Flex-E, and all the work that's being done here in the control plane shall reference or has to reference the data plane definitions of the IT2 recommendation G709.
Perfect. May I request you to actually send me email with the exact reference? Yeah.
Okay, the time is up. We give you 5 minutes. We don't want to steal more time to the break, also to give the next working group the time to set up. So please use your 5 minutes as best as you can.
Okay, I think 2 minutes is enough. Yeah, the first one, I think with Flexi, we don't need to wait for the, beyond the 100 gig Ethernet, 5 Ethernet standard. For example, we don't need to wait for the publishment of 400 gig Ethernet standard. And so based on the use cases, I think currently the control plan should provide the solutions to control Flexi to indicate its relationship with the server layer, with the client layer. How can Flexi be used to bonding more than one file and to provide a high bandwidth? And how can Flexi be used to provide the service allocated resources for the client? That's all. So that's.
Okay, thanks a lot for being super quick. One comment only, please.
Yeah, one very quick comment. I think we have now a set of Flexi-related drafts, and my recommendation would be, can the authors work together to come up with a single set of drafts addressing Flex-E signaling and routing?
Yeah, just look at a spot. Perfect, actually, segue for me. So we are meeting right after the meeting. So in front of the registration, anybody who is interested in, we actually going to talk about this aspect. So please, you're welcome to join us.
Okay, thank you very much. Thank you all. See you in Korea. where we will ask for a little bit more time given the huge amount of new drafts that we have. Thank you.
Anyone say another question?